Hello, everyone. Welcome to another edition of Coffee and Capture. I'm your host, Greg Council. So as usual, I'm going to pick a topic and spend about 5 to 10 minutes blathering on that topic. Hopefully it'll be interesting to you. And as always, you're free to ask me pretty much any question as long as it relates to intelligent document processing, otherwise known as intelligent capture. So let's go ahead and get started. Today's topic is going to be on proofs of concepts and evaluations. And the reason why I'm blending those together is because the things that you're going to want to consider and want to do are pretty similar. It's just the level of investment that is the difference between evaluations and proof of concepts. So we have created actually a playbook. We did a webinar with DocuLab's Rich Medina, and we turned that into an ebook that walks through all of the concepts and factors that you will want to address within the confines of a proof of concept. But here I'm going to take a couple of those nuggets and dig in a little bit deeper. So let's start with key factors that drive evaluations or should. And I have that should in parentheses because there's quite a bit difference or space between what is and what should be. We see a number of clients that come to us looking to do evaluations or looking to add us to a proof of concept where they haven't quite figured out what they want to do. And definitely don't fully understand the art of intelligent capture and what they really need to consider. So there are two factors, and these are in order of priority. The first one is performance. Intelligent capture, and I say this a lot, and I think it always bears mentioning again, is that intelligent capture, unlike other enterprise business applications, is quite different because rather than focusing on capabilities in terms of features and functionality that it brings to bear, let's compare it with a customer relationship management system. CRM, whether you use Salesforce or some other type of application like Microsoft Dynamics, or they call it 365 now, it's quite possible through a simple demo and a review of the capabilities on a data sheet or a brochure or a manual to understand whether or not a solution is going to be able to fit what your needs are. But intelligent capture is quite different because the value proposition of intelligent capture is all about optimizing the amount of structured information out of unstructured documents, maximizing how much output you can get out of it at the highest levels of accuracy. So it's quite a different thing. So the first and biggest factor that is going to be this, means the success or failure of any kind of intelligent capture project is whether or not that system can actually deliver. So that's number one. The second one is really still important. Obviously, it plays into factors of success, things like the cost of implementation, the ability to quickly get into production, the user experience, and of course the systems architecture and how it can support your deployment options. These things, though, are easier to understand with the product literature, whether that's the manuals or any types of ebooks or things like that. So we will cover that too, but lesser so. Performance and measurement. I put a bunch of words in here. These are the do's and don'ts. Kind of like if you're of a certain age, if you remember Highlights magazine with Goofus and Gallant, you had one guy always doing the right thing and the other guy not doing the right thing. So I'm going to kind of take and riff off of that and talk about a little bit of the do's and don'ts of how you should measure performance. So first one is, do ask your vendor to provide the configuration. The reason being is because even though the systems are designed to tackle the same problem, they all do it in a different way, and it's not practical for you to try to learn any bit of this software to the level of proficiency where you can gauge or successfully gauge the true performance of a system. So don't expect to configure this thing yourself. Don't expect to take receipt of this software and learn things to the level of proficiency that you really need to be at in order to gauge how well the software performs. None of this is magic, regardless of what marketing tells you, okay? Second one, do your own measurements, right? Don't take the vendor's word for those measurements. Everybody talks about 99% accuracy. What vendors don't tell you is what that really means. And I'm not going to go into it too much here because we have a lot of information on our website and ebooks meant to educate you on exactly what accuracy really means and what you really get. We've done a number of webinars on that too, but you should do your own measurements once you understand how to measure. Another one that's related to measurements is measure at the task level. So in this case, within the intelligent capture or intelligent document processing world, a task equates to something that we would typically manually do with a document. Now that could be orient the document if you're scanning the document, or making sure it has the right orientation, or making sure that it has the right level of quality, with the contrast. Or it could also mean tagging a document, classifying it, splitting documents, a number of different pages and grouping them into documents if they're multi-level or multi-page documents, or doing the data entry. So each one of these things is a discrete task. Don't measure at the page level. And the reason why I say that is when you're talking about data entry automation. So let's say you've got a process where you've got staff looking at pages and looking at the data on those pages and entering them into a system of record. Each one of those fields represents a task. If you're going to measure, and we've come across clients who have these expectations, if you're going to measure at the page level, what percentage of pages are 100% accurate, meaning you're getting 100% automation, you're not going to see that a whole lot of that is going to be going straight through. It's more important to look at the task, because the tasks represent the actual effort, the labor, the cost savings, not at the page level. Unless you're going to do page-based classification where you can really see how the system performs on a page, a page is classified as one thing or another, it doesn't make sense to measure at the page level. And so we're going to go into that a little bit more so you can understand that. The next one, do use your own curated sample data. Don't take sample data from the vendor. This is just like any other thing. What you see in terms of a demonstration and early examples don't always represent the true nature of the product and the true nature of the capabilities. Vendors are smart in terms of presenting their best face. So use your own data. Do split your sample data into configurations and training sets. So as the first one says, ask the vendor to configure the system. Don't try to do it yourself. When you ask a vendor to configure a system for a POC or an evaluation, provide them with one data set that they can use to configure the system, but don't provide them with the data set you're going to use to test the performance, because there are always ways to game the system, right? If you want to process invoices, let's say, and you've got a case where you deal with over 1,000 different vendors, it's not practical in production to have to create a template for each one of those vendors. What you're going to want is something that is smart enough to find the data regardless of the layout. But if you provide sample data and you test on that same sample data, a vendor could easily take a lot of time and create templates and present really great performance, but it's not really practical to do something similar in a production environment. So separate those sample data into configuration and then a blind test set that only you have that you can measure against. Do always try to measure programmatically. So one of the things with sample data is you're going to want to provide a lot of it. You're going to want to provide a pretty good amount for configuration for the vendor, and you're going to want to have quite a bit for your test data. So you're going to want to measure that programmatically. You're going to look at take your data, run it through the system, get the output, and then have some sort of utility. Typically, the vendor should be able to provide you with a utility to compare the output against what you expect it to be. Don't evaluate visually using a small sample set. That will not give you any clear understanding of what the performance of the system will actually get you in production. End of story. Lastly, do measure both system accuracy on all output and the accuracy at a specific confidence threshold. So the first one is pretty important, system accuracy. What that really means is if you're going to take a bit of sample data, run it through a system, the system accuracy basically is how much of all of that output that the system is able to produce, how much of that is accurate. So you can basically say if it's 95% accurate, that means that 95% of all output data is correct. That's important to know because you can do an apples to apples comparison. It's also important to know if you plan on reviewing every single bit of your data. And quite a few organizations, I would actually claim that the majority of organizations that use intelligent capture in some process are reviewing 100% of it. There are a whole lot of reasons for that. I'm not going to go into them right now, but ultimately, system accuracy is different from straight-through processing. So measure system accuracy. The second one is all about how much of that data would you like to go through without any kind of human intervention. Some vendors call it straight-through processing, as we do, but it all hinges on capabilities of the system to be able to statistically determine what data is likely good at a particular accuracy level and what data does need to be reviewed. So that involves measuring output at specific confidence thresholds. And again, we've got a bunch of different educational materials that explain exactly how to do that. So this is a little bit more about why you want to measure tasks and not the page level. So in this case, let's say we're doing receipt data extraction, and we know that receipts aren't your classic fixed form. You have to do a lot of configuration in order to be able to locate and extract data and then do some sort of automated validation so that you can ensure that it's accurate. These are two different scenarios. The first one is where we are measuring performance at the receipt level. So in this case, we're trying to figure out how much of that data at a receipt level for 5 fields is on 100% accurate. So you can see here at one field, if we're measuring one field, typically you can probably get accuracy levels at 98% because we're measuring one field. But as we add fields to this measurement, we are increasing the level and chance of error, and we're increasing the complexity. And as a result, the likelihood of having 100% data extraction for 5 fields on any receipt is going to be in the low double digits or single digits. But that doesn't really get you the answer that you need, which is how much of this effort, how much of the cost of manual data entry for receipts can I avoid? And that's where we're looking at field level or task level extraction. You can see here at 95% at measuring at a task level or a field level, we can see that you can have 80% of that data entry completely removed if we're measuring at the field level. So that gives you the true sense of what type of cost reductions you can have. That's why it's important. So let's go into the other factors. Now these, as I mentioned, are much easier to evaluate. Oftentimes you can just evaluate the capabilities based on the product literature, whether it's a architecture document or a document listing out the features and capabilities, or through a demonstration or through recorded videos. So but these are still important. The first one is really understanding the cost to configure a system. You know, this is also known as the effort that it takes to learn how to configure the software and the time it takes to do it. Now, in the last couple of years, we've been talking about ease of use, and that's certainly something that we really emphasize. The majority of the marketplace has been embracing that ease of use factor as well, because it's really important. I've been talking about the inability for intelligent capture to truly scale. And what I mean by that is not scaling from a throughput sense, but scaling to be able to use it in all parts of the organization. And the reason being is it's typically been really complex to get really high performance out of the system. So most organizations have limited implementation of intelligent capture to the biggest, most costliest processes, because it takes a lot of effort to learn the software. Oftentimes, organizations will pay a lot for professional services to implement it. So there are two aspects around this: user configured versus software defined systems. User configured systems are those systems where you're going to focus on understanding how a system is manually configured using sample data. This is the classic drawing boxes around structured forms, or creating tag value pair rules or regular expressions to locate data. Software-defined systems increasingly are using sample data to configure, to automate the configuration process. You know, with the objective of doing it, completely configuring a system, including tuning. And that's what we're focused on with smart learning. Smart learning does that, so it's more of a software-defined system. The other factors you're going to want to understand whether or not a vendor uses real, I call real machine learning versus knowledge-based oriented learning. There's a big difference here. One of which is just from an architecture perspective, just the aggregation of creating rules that are stored within a database, a relational database, whereas machine learning is combing through just tons of information, trying to infer the best types of ways to be able to perform a task and automate it. The third bullet point in this cost to configure a system is how much of this can be accommodated as commercial off-the-shelf software versus how much of this is professional services or even worse, development types of processes. So increasingly what we're seeing is this kind of out-of-the-box capability. There are trade-offs. This lends into the next bullet point, which is production readiness, how quickly you can get a system in place and start benefiting from automation. When you see out-of-the-box capabilities, there are trade-offs. So realize that there are trade-offs if a vendor says, like we offer pre-built and pre-tuned invoice data extraction. We offer pre-built claims classification and claims data extraction. There are trade-offs though, because if it's already created and it's already tuned, your ability to train the software on your own data sets is pretty limited. But then there is the software-defined approach, which technically can take some of this out-of-the-box capability and then use that as kind of priming the pump, and then it can start from there, but then gradually start to learn and then optimize performance on your data set. So there is the promise within a software-defined system to be able to do that. User experience is also important, but it's going to be important for user adoption where you actually are implementing or integrating intelligent capture within an existing process. But one of the things you're going to want to really understand is how much of the process needs to change in order to avail yourself of intelligent capture. Are you going to require staff to learn a UI and to essentially train the system to be able to do its job? The last one is architecture and deployment. This really gets to the case of whether you need a cloud type of software, something that supports the cloud, is cloud friendly, whether you prefer the software to be on-premise or a hybrid of the two. So it could be a private cloud, it could be part of the software is located on-premise, part of it is in the cloud. So it's really important to understand what your deployment options are and what you need in terms of a deployment. Do you want software as a service with either self-service, so it's a vendor that has everything up there, it's multi-tenant, and you are creating the configurations and you're uploading the documents, or do you want something turnkey that's either a software as a service or a platform as a service where all you want access to is an API, you're uploading your documents, you don't have to do anything about configuring the system, you don't have to do anything about validating the data, you're just getting the data back at arguably, and lots of it, at a high level of accuracy. These are all different types of things. I have this multi-tenant with the SI ultimately, because multi-tenant is really only necessary if you're going to tap into a software as a service, and you really don't need to understand how they do it. Arguably, any software as a service offering is multi-tenant, and if they aren't, it's not software as a service. So the upshot, don't be afraid to get really educated about intelligent document processing / intelligent capture before you go into this. So educate yourself, get demos, read the literature, talk with analysts, talk with consultancies like DocuLabs, get a good grounding in what the software does before you actually go into an evaluation or a POC, because it's really important to have a good grounding before you even take any time to learn what the software can do, because chances are if you don't, you're going to be wasting your time. You have to be educated or there's going to be a high risk of failure. You need to know what type of deployment you want, what levels of accuracy, how much data you need to get out of the system at a specific accuracy level to meet your business objectives before you engage with the software vendors. Have your use cases defined. So your range of documents, specifically what tasks you want to automate at what accuracy levels, and then have the sample data ready to go in those split cases of configuration data as well as the test data. So that's it. At this point, I'm open to answering any questions you may have.
Hi, Greg. This is Rebecca. So we do have 2 questions that have come in, and the first one is basically taking a step back. It looks like so why do a proof of concept?
Yeah. So hopefully, I guess the intent of this whole presentation was to explain some of why you need to do it, but we can step back even further. Increasingly, organizations can't really have IT projects go awry or fail. I think anybody that's dug into it on the technical side understands that there's a high risk of project failure. You read the literature, it's easily 50% or more of these IT projects don't deliver on expectations. And the reason being is because they rush into adopting a technology, or they rush into adopting a specific solution without really understanding the capabilities, without really running it through its paces. If you're going to go buy a car, sure, you're going to educate yourself on what the car's features are, and you're going to want, and you can see what it looks like when you go online, but ultimately you're going to want to drive it. You're going to want to see how it feels. What does the interior look like? What's the experience look like? It's the same, if not obviously 10 times that more important when it comes to software, especially expensive software. And increasingly organizations are using more sophisticated evaluations or proofs of concept to run and compare different solutions, run them through their paces to see how well it works for them to reduce project risk. And so it's really all about risk reduction.
Okay. And then for the second question, is it a matter of putting together the right checklist of features in order to conduct an evaluation?
Yeah, so like I said, features are important, but features are secondary to the performance of the software. At this time, we're in 2020. The need to understand whether software has the capability of being able to support regular expressions or to be able to create zones is way beyond the point. Every vendor has that kind of capability. That's kind of table stakes. It doesn't even make sense to even issue an RFP to find out if software can do it. Can software support semi-structured data like invoices versus structured forms, or can it support PDFs? All of that software can do all of that. You're wasting your time if you're fixated on features and functionality. As I said at the very top of this is that the main value proposition, if not the only value proposition of intelligent capture, is how much of that unstructured document-based information can you get out of a system and at what accuracy level? That is it. That is the big thing. Features and functionality are a path to do it, but ultimately you need to focus on having really good sample sets and then focusing on the output of those systems. How it's configured, things like that are important, but it's secondary to the performance of it. Where you want to focus on configuration is how hard is it to configure? Getting an understanding of how quickly can you be up into production, not with what is necessarily does the GUI look like, or does it have the ability to define labels and extract values based on proximity. All of that is just noise.
Thanks, Craig. That's it in terms of questions so far.
Okay, well, with that, I think we can conclude. We are about 5 minutes to the top of the hour, so thank you for joining, and we'll see you next time.